Determining the correct voltage for your baseboard heaters is crucial for safe and effective operation. Connecting a heater to the wrong voltage can cause damage or create a fire hazard. If you are unsure, always consult a qualified electrician. However, here are some steps you can take to try and identify the voltage yourself. Firstly, examine the plug on each heater. Plugs provide a visual clue. A 240-volt heater often uses a 3-prong plug, comprising one hot wire, one neutral wire, and one ground wire. Conversely, a 120-volt heater typically has a 2-prong plug, featuring one hot wire and one combined neutral or ground wire. However, be aware that this is not a foolproof method, as plugs can sometimes be changed. Secondly, use a multimeter to measure the resistance. A multimeter is a versatile tool that can measure voltage, current, and resistance. To determine the heater's voltage, you will need to measure the resistance between its terminals. Firstly, ensure that the heater is disconnected from the power supply. Secondly, set your multimeter to the ohm scale. This is usually represented by the omega symbol. Thirdly, connect the multimeter probes to the 2 terminals of the heater. Fourthly, read the resistance value displayed on the multimeter. A 120-volt heater typically has a resistance of around 12 ohms. A 240-volt heater, on the other hand, usually exhibits a resistance of approximately 48 ohms. These values are based on common wattage ratings for baseboard heaters. It is important to note that these are typical values, and the actual resistance may vary slightly depending on the heater's wattage. To understand why the resistance differs, consider the relationship between voltage, current, and resistance as defined by Ohm's law. Ohm's law states that voltage equals current multiplied by resistance, or volts equals amps times ohms. We can rearrange this formula to solve for resistance. Resistance equals voltage divided by current, or ohms equals volts divided by amps. For a given power output, a higher voltage will result in a lower current, and thus a higher resistance. For example, let's assume both heaters have a power rating of 1500 watts. The 120-volt heater would draw a current of 12.5 amps, calculated as 1500 watts divided by 120 volts. Using Ohm's law, the resistance would be 9.6 ohms, calculated as 120 volts divided by 12.5 amps. The 240-volt heater, drawing the same 1500 watts, would only draw a current of 6.25 amps, calculated as 1500 watts divided by 240 volts. Consequently, the resistance would be 38.4 ohms, calculated as 240 volts divided by 6.25 amps. It is worth mentioning that the formula used to find watts is volts times amps, and watts equals volts squared divided by ohms. These calculations are simplified examples. Real-world resistance values might vary slightly due to manufacturing tolerances and other factors. Furthermore, you can consult the manufacturer directly. If the plug and resistance measurements do not provide a definitive answer, contacting the manufacturer is the next best step. Locate the model number on the heater. This is usually found on a label attached to the heater's housing. Contact the manufacturer's customer service department via phone or their website. Provide them with the model number and any other identifying information you have. They should be able to tell you the correct voltage for your heater. Before installing your baseboard heaters, consider a few additional safety precautions. Ensure that the circuit breaker or fuse is turned off before working with any electrical wiring. Use appropriately sized wiring for the voltage and amperage of the heaters. Consult the National Electrical Code, or NEC, for guidance on proper wiring practices. For example, NEC Table 310.15b16 provides ampacity ratings for various wire sizes. Ensure that the heaters are properly grounded. This is essential for preventing electrical shock. Follow the manufacturer's instructions for installation and wiring. These instructions will provide specific guidance for your particular model of heater. If you are unsure about any aspect of the installation process, consult a qualified electrician. Improper installation can create a safety hazard. When connecting the heaters to the electrical circuit, make sure to use the correct type of wire connectors. Wire connectors should be sized appropriately for the wire gauge being used. Use wire connectors that are listed for the intended application. Wire connectors should be installed according to the manufacturer's instructions. Securely tighten all wire connections. Loose connections can cause arcing and overheating. Inspect all wiring for damage before energizing the circuit. Replace any damaged wiring. Use a voltage tester to verify that the circuit is energized before working on it. A non-contact voltage tester can be used to check for the presence of voltage without touching the wires. After completing the wiring, double-check all connections and ensure that all covers and access panels are properly installed. Turn on the circuit breaker or fuse and test the heaters to ensure that they are working properly. Monitor the heaters for any signs of overheating or other problems. If you notice any issues, turn off the circuit breaker or fuse, then consult a qualified electrician. Always remember that working with electricity can be dangerous. If you are not comfortable performing these tasks yourself, it is best to hire a qualified electrician. They have the knowledge, skills, and experience to safely and properly install your baseboard heaters. While measuring resistance is a useful technique, it's important to understand its limitations. The resistance values provided earlier are typical values for common wattage ratings. However, the actual resistance may vary depending on the heater's specific design and wattage. For example, a low wattage heater will have a higher resistance than a higher wattage heater operating at the same voltage. Furthermore, the resistance of a heater changes with temperature. When the heater is cold, its resistance will be lower than when it is hot. Therefore, it is important to measure the resistance when the heater is at room temperature. If you are measuring the resistance of a heater that has recently been used, allow it to cool down completely before taking the measurement. In addition to measuring resistance, you can also use a clamp-on ammeter to measure the current draw of the heater. A clamp-on ammeter measures the current flowing through a wire without having to disconnect the wire. This can be a useful way to verify that the heater is operating at the correct voltage. Firstly, ensure that the heater is connected to the power supply and is turned on. Secondly, clamp the ammeter around one of the wires supplying power to the heater. Thirdly, read the current value displayed on the ammeter. Compare the measured current value to the expected current value for the heater's voltage and wattage. The expected current value can be calculated using the formula amps equals watts divided by volts. If the measured current value is significantly different from the expected current value, it may indicate that the heater is connected to the wrong voltage. For example, if you measure a current of 6.25 amps on a heater that is supposed to be operating at 240 volts and 1500 watts, this would be a normal reading. However, if you measure a current of 12.5 amps on the same heater, it may indicate that the heater is connected to a 120 volt circuit. In this case, the heater is drawing too much current, which can cause it to overheat and potentially start a fire. When using a clamp-on ammeter, it is important to clamp the ammeter around only one wire at a time. If you clamp the ammeter around multiple wires, the magnetic fields from the wires will cancel each other out, and the ammeter will not read the correct current value. Also, remember that safety should always be your top priority when working with electricity. If you are not comfortable performing these measurements yourself, consult a qualified electrician. They can safely and accurately determine the voltage of your baseboard heaters and ensure that they are properly installed. Finally, when selecting a location for your baseboard heaters, consider the following factors. Firstly, place the heaters along exterior walls, preferably under windows. This will help to counteract heat loss from the windows and keep the room warm. Secondly, avoid placing furniture or other obstructions in front of the heaters. This will block the flow of heat and reduce the heater's efficiency. Thirdly, ensure that the heaters are properly grounded. This is essential for preventing electrical shock. Fourthly, follow the manufacturer's instructions for installation and wiring. Fifthly, if you are unsure about any aspect of the installation process, consult a qualified electrician. By following these steps, you can safely and effectively determine the voltage of your baseboard heaters and ensure that they are properly installed. Remember that safety should always be your top priority when working with electricity.